Hello guys, I'm Aravind. So good evening everyone. So today we are discussing about the LeetCode daily challenging problem. So today problem is actually it's very easy. We are going to dealing with array with the prefix sum of sliding window concept. So before we are jumping into the problem, please support me. This is the second video. So daily basis actually I plan to give some video to solve the daily base problem is given by the LeetCode. Okay, let's move on to this problem. So actually, we were one thing before we are going to solve this problem. Actually, we have to read this problem statement very clearly. This problem is really too simple, but only thing is like we have to read the given problem statement clearly because there is some little catch here and there. You have to figure out properly. Once you figure out properly, definitely it's really easy to write the brute force approach. It's really easy to write the optimized way also. Throughout this journey, I will here to help you to understand the given problem statement along with the brute force code as well as some optimized approach. Okay, let's move on to this problem. The problem name is the K radius subarray. This is a LeetCode medium problem. Okay, what they are trying to say. So you are given zero indexed array. Okay, the number of n integer and integer k. So what they are trying to say, they will give two input elements. One is array, another one is integer k. Okay, fine. So what you are going to do with that? The k radius array for the subarray. So what is subarray? Subarray is a contiguous element. Let's take this example. So the 7439, they are really contiguous, right? This is one subarray and 439. So this is also this is one of the subarray. Let's consider 39 and 26. 39 and 26 are contiguous, definitely not. So they are not a subarray. So subarray is nothing but it's a contiguous element. It's called subarray. Okay, the k radius average of subarray centered at some index I with radius k is average of all elements in number array between I minus k and I plus k. Okay, if there are less than k elements before or after index I, then k radius average is -1. Okay, fine. So what they are trying to say, let let's take this example. Okay. Uh, okay. Okay. Let's take it. So these are two inputs that this is the number array. This is the array is that given that k equal to 3. Okay. So what they are trying to say, just make your so okay. Let's stand at any point. Let's say actually I'm standing at 9. So what they are trying to say, you have to take the subarray summation. I mean the average subarray k radius average for subarrays. Okay, let's say I'm standing at here. I'm standing at here. In that case, so what you have to find? You have to find I minus k to from. So your iteration from I minus k to I plus k with average subarray sum. So what does average mean? So total numbers, a summation of all the elements divided by number of elements. That is average, right? So what you have to find, you have to find out the average k radius subarray average. Okay, so this is your set space. So let's say if k equal to 3, so I'm standing at here. Okay, I'm standing at here. I'm making this as bold. What is my I here? So 0, 1, 2, 3, 3. Where my I equal to 3. So what is I minus k? So I minus k is nothing but 3 minus 3 equal to 0. Okay. And uh, I plus k, I equal to 3 and k equal to 3, which means 6. So you have to take the average subarray sum from index 0 to index 6. So which means this is your index 0 and this is your index 6. So you have to take all the summation of particular in between that particular index and divided by how many elements are, so 1, 2, 3, 4, 5, okay, 3 here and then 3 here. Okay, totally 7 elements, right? So first you have to take the summation of all the elements and divide it by 7. That will be your k radius subarray average for this particular index. Okay, let's say, so the answer is there will be one here. Okay, this is the answer for this particular given statement problem. Okay, let's say actually you're standing here and you have to take 3 elements. So the problem is clearly telling. So you have to take. So the reason why they are mentioning as a radius, if you are staying at here, you have to take k number of elements from left, k number of elements from right. So what is the k? K equal to 3 here. So I'm staying here. So I have to pick 3 elements from left side, 3 elements from right side, along with this particular index. So totally 3 elements on the left side, 3 elements on the right side, and I have I, right? So totally 7 elements. Take a sum and divided by sum. So divided by particular 7, divided by number of elements equal to 7, right? So divided by 7. So that will be your k radius subarray sum for the particular index. Okay. So what about this one? In that case, pick 3 elements from the left side, pick 3 elements from the right side. So summation of this subarray along with divided by 7 will be your result for the next index k radius subarray sum. Okay. So what about, let's say, I'm pointing here. So in that case, definitely I don't have anything on my left. I don't have anything on my right, right? Okay, I will make this upload. Uh, okay, okay, fine. Let's say, okay, coming to my problem. Okay, let's say I'm staying here. In that case, there are 3 elements on the left side. Definitely not. There are only 2 elements on the left side, but there is number of elements on the right side. I'm not worrying about, but I need k number of elements from the left side, k number of elements from the right side. The summation, the divided by number of elements. So in that case, I don't have 3 elements from the left side. So what is the case? If they are clearly mentioning it here, so if there are less than k elements before or after index I, then the k radius average equal to -1. So for this particular index, why they are mentioning it -1? Because I don't have 3 elements on my left side, but I have some more elements on my right side. Since there are less than k elements, so I mention it at -1. So there are two cats. One is like, what is your space? So what is your iteration space? Iteration space here equal to the I minus k to I plus k. Okay, I'm okay with that. So so you have to iterate and you have to figure out the summation of all the elements in between this iteration space and divided by number of elements. So that will be the k radius average. So what if there is no more elements? I mean, no more I mean, let's say if k equal to 3, if I don't have the k elements on the left side or k elements on the right, in that case, what you have to do, if elements less than k left or right, then your answer would be -1 for the particular index. Okay, so actually I'm starting here. So let's come into the input. I'm starting here. Is there an 3 element on my left side? No, I don't have any 3 elements on my left side. Okay, the answer would be -1. If they are okay, let's move on to this point. Okay, I have 3 elements on my left side. No, I don't have. Coming to this point, I have a 3 element. No. So while you coming to this point, I have a 3 element on my left side. I have a 3 elements on my right side. So what is that? This is that. This is a subarray. So the summation of subarray and divided by, so how many values? 7 values you have. What is the subarray size? The subarray size is equal to 7. So take a sum and divided by your subarray size. So that will be the result of this. That would give the result by and then I'm moving here. So, and then I'm moving here. So while you're moving, you have to pick 3 elements on the left side and 3 elements from right side, right? In that case, okay, again, your subarray side is equal to subarray side by default, your k equal to 3, right? If your k equal to 3, you need, I need 3 elements from the right. I need 3 elements from the left, along with my particular ith index, right? So what will be the your subarray size? By default, your subarray size, uh, your subarray size would be 2 into k plus 1. You can apply k whatever. If k equal to 3, your subarray size will be 7. If k equal to 4, your subarray size will equal to 5. Okay. If I'm standing here, I'm picking the 3 elements on the left side, 3 elements on the right side. So that totally I'm taking the summation and then I will divide by 7. Okay. Then you will clearly understand what is the given problem statement, right? Okay. Let's move on to the how to write a brute force approach. So, okay, just take this, take this. Okay. Uh, I'll put it here. I'll put it here. Okay. The problem statement is clearly saying, okay, I have to iterate. I know what is my set space. My set space would be I minus k to I plus k for the every index. The meanwhile, shall I, let's say k equal to 3. Shall I start at index 0? Definitely not. Shall I start at index 1? No. 2? No. Okay, I can start at my index k. So in that case, so what you have to do, you have to start your iteration from index k first. Before that, you have to write, you have to construct your result array. I mean, your radius array, radius subarray. So what is your subarray size? So definitely, I have to construct, let's say k equal to 0, I have to construct a radius average for all of the elements. So in that case, definitely my radius subarray size would be the given input, the given the array length. So by default, actually, I will fill -1. Why I'm filling -1? If there is less than element on my left or right, then I will keep -1. Okay. Shall I start at index 0, I equal to 0? Shall I start my iteration 0? Definitely not. You have to start your iteration at k, because if you're starting your iteration at k, only then there will be the k element on the left side, right? So definitely you have to start from k. Okay, then I less than, you have to iterate all the elements, just increment your index. Okay, fine. Okay, I'm good with my very first iteration. Then what you have to do? Okay, I'm starting at here. Then you have to find out all this stuff. I mean, find out the summation. So what is the sum? Where you have to pick the sum. So I equal to your I minus 1, right? I minus k. I minus k. What? This is your set space, right? Then I minus, sorry, j less than or equal to, so I minus k, I plus k, I minus k plus I plus k. Okay, okay, I plus k, implement this particular function. Okay, take a sum, take a sum, just declare one temp variable here, and increment your temp variable simply over here, increment your temp variable simply over here, and add it to your the radius summation and radius simply. This is very simple. This is very simple brute force approach where we're going to add this temp variable. Simple. This is, I'm just writing up a bit pseudocode, up a bit the problems in JS code. This is really very very simple problem statement you can solve by using the brute force approach. So what is the time complexity over there? Let's take this array. Just consider the worst case. Worst case. Let's say if k equal to 0. Shall I pick this element? Definitely you know. You can, right? There is 0 element on the left side, 0 element on the right side. In that case, you can consider all the elements of the given array. So definitely, if consider the worst case, if k equal to 0, you have to iterate all the elements from 0 to n minus 1. Okay, so definitely your outer loop for worst case, both your outer loop, both your inner loop will run from O to 0 to n minus 1. So definitely your time complexity would be O of n square, O of n square, and your space complexity would be O of n, because you have to create separate array, because I don't want to tamper by the given input array. So definitely that not that might not be possible, because for the you have to create a separate radius subarray. So whatever the variable name you want, so that would be the size of your given the number array. So the space complexity will be O of n, and time complexity will be O of n square. This solution definitely will give TLE exception, because let's say if the given input element is 10 to the power of 5, in that case your problem will run. So your product, what is the number of 10 to the power of 10? Then definitely this will give TLE exception. You have to write your code less than 10 to the power, approximately 10 to the power of 8 less than, and 10 to the power of 9. So this problem will give the TLE exception definitely. So what we have to do? Okay, this is the problem statement. Okay, this is the problem statement. So there is a one little catch over there. Okay, let's say if I'm starting over here, so what I have to do? I have to pick three elements, right? Left side. I have to pick three elements on the right side. Okay, fine. I'm fine with that approach. Okay, let's say if I'm starting over here, if if I am starting with this index. So what I have to do, I have to pick three elements on the left side. I have to pick three elements on the right side. So let's see this image. For this particular index, they need a summation from 0 to 6 index. Okay, fine. For index 4, they are taking the summation from 1 to 7. What they are doing here? There is some repetitive sum. Yes, definitely. From 0 to 6, they are taking some. Again, 0 to 6, they are taking some. Again, they are taking summation from 1 to 7. Already the summation happened for the from 0 to 6. Again, they are taking the summation from 1 to 7. So what is that? There is some repeated summation. If it is repeated summation, what we have to do? If it is repeated summation, definitely you have to solve this problem using PrefixSum. This is one of the interesting catch. I got this in this problem. Okay, I can able to solve this problem using the PrefixSum because of the repetitive summation. Okay, what about nest? Okay, I'm starting here. I'm taking the summation from 0 to 6. Okay, fine. I'm starting here. In that point, actually, you're taking summation from 1 to 7. 1 to 7. So 1 to 7. And the very next iteration, you're taking the summation from 2 to 8. So what is over here? So the very first term, 0 to 6, and the next iteration, you're just removing one value from the left side, you're just adding one more value from the right side. And the subsequent, for every subsequent operation, you're removing the one element from the left side, you're adding one element from the right side, right? So it's like there is a sum size. So for every subsequent request, it's sliding over. How it's sliding? Because there is one string as before. They are extending uh, at the right side, right? So swing at the left side, swing at the left side, expand at right side. So this is it's simply illustrating the sliding window. So what you have to do, you have to solve this problem PrefixSum along with sliding window, because okay, I know what is my iteration space. So this is your iteration space, right? I mean, you have to start where I equal to k, because before the k index, definitely there is a no possibility of k element on the right side. Okay. Okay. What about okay, as well as there is one more little catch over there. Actually, they are stopping. Okay, they are starting at index 3, 4, 5. But why they are not doing the iteration for 6? Because there is no more element. There is no more. There is no three elements on the right side, right? So that's why. So you have to start with k, as well as, let's say, you have to start with, okay. You have to start with k, index k, as well as end with where they are ending. They are ending with okay. And so you have to stop with iteration equal to yes, the array length -1 and -k. So you have to start and you have to end with, okay, let's say if array equal to 3, your starting index will be 3 as well as your ending with that sixth, I mean index, where index equal to 5. How you have to find this one? Let's say your array size is 3, 6, 9. Okay, 9 minus 1, 8, and 8 minus k equal to 5, right? So you have to start with 3 and end with k. So it simply start with k and end with array length -1 and minus of k. Okay, fine. So how we are going to solve this problem? First, we have to construct your PrefixSum. How we are going to construct your PrefixSum? It's very simple. It's very simple. I will show it here. So I said like, okay, I can solve this problem using PrefixSum with sliding window. Sliding window, right? Okay. The very first time actually I have to create a PrefixSum. This is the part to create. I'm just declaring the PrefixSum array. So PrefixSum is nothing but the current index value. The current index value is summation of all previous value along with current index value would be the PrefixSum value for the particular index. Let's say for take this index. What is the summation? 7. So what is the current value? 4. So summation the PrefixSum value for this particular index would be 11. Okay, I'm just constructing my PrefixSum over here. So along with that, okay, so you're taking the average, right? So you have to divide number of values. So to finding the number of values, this would be the formula. Let's say if k equal to 3, already I said if k equal to, they are picking 7 elements, right? 2 into k plus 1. This is very simple problem formula. You can't get it anywhere here. You will simply understand the problem. Definitely you will make a formula with yourself also. This is the formula for the number of elements. So number of elements in the subarray size k. Okay, so I just constructed my PrefixSum over here. I know what is the number of elements, so this will be definitely will be used later. While after getting the summation, I will divide this value. Okay, okay. Coming to this problem, already I said, so this is our iterate space. So I have to start with k. I have to start with k, uh, end with array length -1. So that is what actually I'm doing here. I'm doing my for loop, start with k and end with I minus number array length -1 and minus k. So this is what actually I'm doing. Okay, once I started over here for this particular for the very first iteration, I don't want to do any manipulation. Let's say I'm starting over here. I'm starting over here. So what is my subarray? Your subarray would be from 0 to index 6. In that case, I need PrefixSum value of 5 because I need summation of all the values. So I'm simply taking summation of the PrefixSum of index rate. PrefixSum of index k, you will get I plus k. So you will get the PrefixSum of index k, and I will do divisor over here. And if my I not equal to k, in that case, what you have to, on the very subsequent iteration, you're just removing one element, right? So what I'm doing, I'm just removing one element from the left side. I'm adding one element on the right side. So which means I need a PrefixSum of index 7, but I don't want the PrefixSum of index 0. So in that case, consider this blue line. In this blue line, so take the PrefixSum of index 7 and just deduct the PrefixSum of index 0. If you do that, definitely, right, you will get the summation from index 1 to 7. I'm taking the entire summation from 0 to 7 and I will just deduct the value of index 0. I will get the summation of 1 to 7. So that will be the average summation for this particular index, and my array iteration will go on from 0 will move on to 3 to 4 5, and after that you will get exit because that is it will exceeding the for loop, and I will return my subarray. Very simple. Okay, what is the time complexity? Definitely the the PrefixSum will take the space complexity of O of n. I'm sure of that. I'm very much sure. Even the average, I'm creating the separate array for my result. That is also take the space complexity of O of n. So for the time complexity, constructing the PrefixSum, I have to iterate all the index, right? So definitely the time complexity will be O of n for this particular statement, O of n for constructing the PrefixSum, and as well as if, let's say, for the worst case, if k equal to 0, in that case, I have to iterate all the index elements. In that case also, the time complexity will be O of n. So to O of n, just remove this constant value. Your time complexity will be O of n, and your space complexity would be O of n. So this is the optimized approach. So thank you guys. This is really interesting problem. So the prefixum is one of the important concept in array. So prefixum and sliding window, those are really important and interesting one. So thanks for watching this one. Let's meet on tomorrow. Thank you.